What are the characteristics of algorithm? Once we are writing the algorithm, what all should be there inside the algorithm? That is nothing but the characteristics of algorithm. Pseudocode is a combination of natural language plus the programming language. Combining these two, you are representing the algorithm or you are defining the algorithm. That is called as pseudocode. How we are giving a name to the algorithm? We are giving the problem whichever we are solving for, that as a name for the algorithm. Hello everyone, welcome to one more session on data structure. As we are discussing about the data structure, today we'll continue our discussion with the second session of first unit, specially for second semester B.Ca students. Myself, Indu, Faculty of Computer Science Department, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. Let's start today's discussion. So what we are going to discuss in today's session is all about algorithms. When we are writing the program, the first step before writing the program is to write the algorithm. As all of you know what is algorithm, algorithm is a step-by-step representation for the solution. How we are going to find the solution using the programming. Before that, we blueprint something, what have to do. That is called as algorithm. Okay, definition, formal definition for the algorithm is, an algorithm is a finite set of instructions that if followed accomplishes the specific or particular task. If you are finding a difficulty to get this statement, we have one more definition for the algorithm. That is, algorithm is a step-by-step procedure used in order to solve the particular problem. Isn't it easy? Yes, right. So you can make a note of it. Algorithm is a step-by-step representation to solve any given problem. This is a definition for algorithm. What are the characteristics of algorithm? Once we are writing the algorithm, what all should be there inside the algorithm? That is nothing but the characteristics of algorithm. First, we are writing the algorithm to solve the particular problem. So, we should have some input, right? That is a first character what we have. An algorithm has 0 or more input taken by or specific set of objects. And what is the second? Once we are giving the input, what we are expecting that is called as output. So the second character is output. For any algorithm, there should be one or more output mandatorily. Until unless you don't have input and output, it is not called by an algorithm, right? So an algorithm has one or more outputs which has a specific relation to the given input. Output should be related to the given input. It could not be something else, that is something garbage value or something like that. It should be related to the specific problem and to the input what we are giving. Then the third characteristic what we have is definiteness. Definiteness means you should be very clear when you are defining the steps for solving the problem. There should not be an ambiguity in the definition, or there should not be ambiguity in the steps. Very clear representation of the steps or the instruction is definiteness. Each step must be previously defined. Each instruction is clear and unambiguous. There should not be any ambiguity. Fourth characteristic is finiteness. Finiteness means you should have a finite number of steps. One step and the second step, two steps should not repeat itself. Finite number of the steps. It should not go to infinite loops. So that is called as finiteness. The algorithm must always be terminated after the finite number of steps. Then effectiveness. Effectiveness means what? For given input, we are getting the proper output or not. Whether the algorithm is working effectively for the problem what we have designed. That is called as effectiveness. All the operation to be performed must be sufficient with the basics, what they are input we are giving and what output we are getting. So these are all the basic characteristics when we are writing or designing the algorithm. What is the first one? First one is input, second one is output, third one is definiteness, fourth one is finiteness, and fifth one is effectiveness. After these characteristics, we move on to representation of algorithm. How all ways we can represent the algorithm? We can represent the algorithm in three different ways. One is natural language. What do you mean by natural language? As we are speaking today, as we are communicating right now, that is called as natural language. You can write the steps as you write the stories. So that is nothing but representation of algorithm using a natural language like English-like languages. Second representation is using the pseudocode. What you mean by pseudocode? Pseudocode is a combination of natural language plus the programming language. Combining these two, you are representing the algorithm or you are defining the algorithm, that is called as pseudocode. It's a combination of natural language and the programming language. It skips most of the issues of ambiguity. It's always better to use pseudocode representation while we are writing the algorithm. Third type of representation is flowchart. Whatever we do here in the pseudocode, that will be represented in diagrammatic format. That is called as flowchart. It is a graphical representation of an algorithm. As you know, stat will be represented like this. So variables are represented like this. Conditional statements are represented with diamond shape. So these are all different types of representation while we are representing the algorithm in the graphical representation. This is all about how we are representing the algorithm. So next what we have is a specification of algorithm. What specification you must have when you are designing a algorithm or when you are writing the algorithm? The first specification is that algorithm to be has its own name. Without name, we cannot recognize anything, right? Similarly, algorithms should have its own name. How we are giving a name to the algorithm? We are giving the problem whichever we are solving for, that as a name for the algorithm. It specifies the problem to be solved, right? Algorithm name always specify which problem we are solving. The second specification is number steps. How many steps the algorithm should terminate or how many steps we have to solve the problem. So number of steps is one more specification. Identification, tags and instructions. What is number of steps? We are declaring variable, we are having conditions, we are having some instructions to be executed. All will be represented in different steps. So next, third point is explanatory comment. Algorithm should not be confusing. It should have explanatory comment for each line wherever it is required. Right? It describes the operation. It should be written with the pair of square braces. What we are writing within this pair of square braces, that should be explained. Explanation should be given for steps where it is required. And then the fourth specification is termination. Algorithm should not be abruptly stopped. It should terminate properly. What do you mean by terminate properly? It should execute itself and terminate by giving the output properly. That is nothing but termination. It specifies the end of algorithm. It is generally using the stop keyword. How we are terminating the algorithm? Using the stop keyword. These are all some of the specification we should keep in mind when we are writing a algorithm. What are the specification? First thing, algorithm should have name. Each step or each instruction should be named with the step number. That is the second specification. And each instruction, whenever it is necessary, should have an explanatory note on that. And then algorithm should terminate properly by giving the keyword stop. When to terminate the algorithm or when to stop the execution, that should be specified. This is a specification of algorithm what we have. Next, we'll move on to the performance analysis. What do you mean by performance analysis? Performance means what? How exactly you are working. That is called as performance. How your performance in the academics will be measured by your internal marks as well as by your external marks, right? Similarly, here the performance of algorithm also measured in two criteria, measured with the two criteria. One is space, how much of space it is required and how much of time it needs to execute. Space, here we represent space as a memory in the computer. Okay, computer main memory is referred as a space here. So let us see what is performance measurement. Performance analysis of algorithm depends on two factors. That is, first one, amount of memory used and the amount of computational time. How we are analyzing the performance? By how much of memory it is used and by taking how much of time it will consume. So, depend on these two criteria, we are going to analyze the performance of your algorithm. An algorithm is said to be efficient and fast if it takes less time to execute and consumes less memory. Okay, as your examination, if you are good in both the way, like internal is also you are scoring good and external is also scoring good, then you are efficient student or you are great student, like that. No, similarly, here also what we are saying, we can say whatever the algorithm we have designed, that is efficient when it requires less time to execute and it requires less memory in the computer main memory. So this is a criteria. So performance analysis depends on basic two factors. That is, we call it as time complexity and space complexity. The amount of time required is a time complexity, amount of memory required is called as space complexity. Let us see what is time complexity. We have different definition for the time complexity. Whichever you can understand or you can remember, you can use that. Time complexity is a concept of computer science that deals with the measurement of amount of time taken by the set of code, a piece of code, set of code, or an algorithm to process or run the functions. Simple, as I told you, is the amount of time required to execute particular piece of program. It's as simple as that. Time complexity is how much of time a program or the piece of program is taking to execute itself. Then other definition, it is simply a measure of time it takes for the function or the expression to complete its task. You can mention like that also. It is simply a measure of time, how much it will take is a measure of time it takes for function or the expression to complete. So this is a definition for time complexity. Next, what we have in time complexities, we have three different cases when we are dealing with the time complexity. As we are having a different cases like best, worst and average cases, here also we can measure the time complexity by three cases. One is worst case. What is worst case? The algorithm taking very large time to execute. That is a worst case. Our efficient algorithm, what it should do? It should take less time to execute, right? So if it is not taking less time, if it is taking large amount of the time, then it is a worst case where how the algorithm has to be executed. And the second case is average case. It is not taking too much of time and it is not taking too much of less time also. It is executing itself on an average basis. That is called as average case. And the best case, what we say, it can be executed. The algorithm can be executed in fraction of time. That is called as best case. It is the shortest time that the algorithm which use over all the instructions of the size n for a given problem to produce a desired output or desired result. N is a number of steps what we are using in the algorithm. To execute all number of steps, how much time? Very short time it is taking. So it is called as best case scenario. Next what we have is space complexity. As we have done with the time complexity, what do you mean by space complexity? How much of memory it is required while executing the program. So that is nothing but space complexity. Space complexity of algorithm is a total space taken by the algorithm with respect to the input. It also includes the inputs. For the algorithm, memory can be used for the following. How memory is used when we are dealing with the algorithm? For variable declaration, if it is my memory block, we have already discussed in the session where all what the data is stored in the memory. Here variables will be stored. Here the instruction, that is text, will be stored, that is program instructions. Here the variables will be stored, and this will be the execution part in the main memory. For these are three types of memory will be allocated when executing the program. That purely depends on these three criteria. How many variables we have declared, how many set of instruction the algorithm has, and how much time it takes to execute each instruction. That all will be represented in the space complexity. A space complexity is the amount of memory used by the algorithm, including the input values to the algorithm to execute and produce the result. Including the input values also be included in the space complexity. As we have done with the three cases of the time complexity, here also we have three cases in the space complexity. That is, worst case, large amount of the memory it is required to execute, then it is a worst case. The minimum space that algorithm will use over the instance of the size n, and the average case is average space consumed by the algorithm to store all the variables, instructions and the execution. And the best case, it is a least space. Least means minimum space that is consumed by an algorithm which uses over the instruction for size n. Minimum space required is a best case, average space required is a average case, large space required is a worst case scenario for the space complexity. Next we are moving on to the asymptotic notation. What do you mean by asymptotic notation? Asymptotic notation is a representation using a mathematical symbols. We are representing the best case, worst case and average case representation. That is called as asymptotic notation. When we are calculating the performance of the algorithm, we should calculate in the mathematical expressions, right? So to represent these best case, worst case and then the average case in the mathematical expression, we are using some of the mathematical notations. Those symbols are called as asymptotic notation. How many asymptotic notations are there? We have three asymptotic notation. What are those? Big O, big omega and big theta. Big O, that is O, that represent the worst case scenario. Big omega, that represent the best case scenario, and theta will represent the average case scenario. Let's see what O, theta and omega will represent. You specify the longest time of the algorithm. It indicates an algorithm's worst case time complexity. What it indicates? It indicates worst case time complexity will be indicated by using big O notation. Then omega. Omega is a notation used to represent the best case time complexity. And theta, it specifies the average time of an algorithm required for all the input values by indicating algorithm's average case scenario. Hope all of you clear. What is to represent the worst case? O is to represent the worst case, omega is to represent the best case and theta is to represent the average case scenarios. We are using the mathematical notation. Let's move on to the performance measurement. What is performance measurement? Measuring the performance based on whatever the criteria we have just discussed, that is time complexity and then the space complexity. Performance measurements is evaluated how much of time and the space particular algorithm has taken to complete the task. Depending on your time and space complexity, we are going to measure the performance of algorithm. As we are measuring the academic performance of any student by taking the internal marks as well as the external mark, here we are measuring the algorithm performance by taking the time complexity as well as a space complexity. On the other hand, performance analysis is calculating in advance how much time and the space of particular algorithm might take. Why we have to go for performance measurement? To calculate how much time algorithm may require while executing, that can be calculated before executing the program. So that's what we are using the asymptotic notation to represent how much time the algorithm can take. Depending on that, the developer can use which case scenario he wants, big O, theta or omega, whichever he want, he can choose on that. The measuring the performance of algorithm can be done in 3 ways. Again, how we are measuring depend on worst, average and then the best cases. Performance measurement: an algorithm which consumes a less space memory and takes a less time to execute is said to be effective algorithm or efficient algorithm. The worst case, if it takes maximum time to execute and occupies a maximum space in the memory. Combining the worst case of both time complexity and the space complexity, we are giving the worst case for performance measurement. Then the average case, algorithm is said to be in the average case if it takes the average time to execute and occupies the average space in the memory. It is called as an average case performance. Then best case, an algorithm is said to be in the best case when it takes the least time to execute and occupies the minimum space in the memory. So whenever algorithm consumes less space and execute very fast, we say that algorithm is in the best case scenario. Next, we'll move on to the recursion. So what is recursion? Recalling. Recalling is called as recursion. Recursion. The function that calls itself is called as a recursive function. So let's see the formal definition of the recursion. Recursion is a technique for defining the problem in terms of one or more version of the same problem. What exactly we are taking? We are taking a large problem. We are dividing that large problem into small problems, and these small problems will call itself. So this is called as recursion. Recursion is a method of defining the problem in terms of itself. What? It is defining a problem in terms of itself only. It is a procedure is defined to solve the problem. Then the same procedure is called by itself one or more times. If you are not understanding right now, just keep in mind that recursion is technique where the function calls itself or the method calls itself. Okay, like for example, you are calling on your same phone. That is called as recursion. So when we solve the example, you can get to know exactly what recursion and why recursion is important and where all we can use a recursion. So let's have some more points on the recursion. A function which contains a call to itself or a call to another function which eventually calls the first function is called as recursive function. The recursion, calling function and called functions are same. What is calling function and what is called function? If you don't know what is calling function and the call function, always the main is calling function. Right, whenever we start the execution, main function is a calling function. Within this main function, I am calling one more function like ABC. So this is called as calling function and this is called as called function. So what here we are saying means here the calling function and called function are same. If I am calling A, B, C, this ABC function should again call itself. So this is called as calling function itself. So this here the solution to the recursive problem is built from the result obtained by the smaller version. This is a smaller version of this. So this result will be given back to the calling function, and again it will repeat itself until unless the condition satisfied. We can reduce the length and the complexity of algorithm using recursion. Instead of writing the same code again and again and again, we can reduce the length of the algorithm. So that is what the formulation of the solution to the problem by using the concept of recursion. Example of recursive program, we'll discuss what are the different examples of the recursive programs we have. Hope all of you clear what is recursion. A function calling itself is called as recursion, where calling function and call functions both are same, and this called function is always a smaller version of calling function. Why we are using the recursion? To reduce the number of steps. Instead of writing the same piece of the code again and again, we are repeating the same function to reduce the code. Okay, this is all about the recursion. This is an example what we have taken for the recursion. Here you can see wide recursion. What is this? Recursion is user defined function. Right, we have some set of statements here, whichever we are solving for. Depending on that, we have set of function. Here, this again we have a function recursion, right? This function in turn calling the function itself. When we have this, the control will goes back to the function, that is user defined function itself. As our execution starts with the main with some variable declaration or printf statement, scanf. After that, here it is calling the function recursion. Once it is called, this is the first step, it will go here. Right, first step, it will go to the called function. Right, in the called function, while we are executing the called function, again the calling function is same as that of the called function. So it will again call back the same function, that is step 2. Until unless this will repeat, until unless condition becomes false. Okay, understood how recursion works. Main function calls one recursion function is called, and when executing the recursion function, again the recursion function is called. So that is called as recursion. When we are dealing with the recursion or a recursive function, there are two major points that we have to determine or that we have to specify. What is the two major points? One is determining the base case, and the second one is determining the general case. What do you mean by base case? Base case always represent when the program or the recursive function has to terminate. That is nothing but base case, base condition, or we can say on that one particular condition, the recursive functions come out of the loop and it will give the result. That condition is called as base case. Another is general case. What is a general case? Whenever each time the recursion executes itself, it will reduce the size of the problem. That is called as general case. There must be the general case in any recursion function such that each call must reduce the problem size and must converge to back case. Okay, that is a general case. What are the two major cases? Base case and general case. Determining the base case, when the execution or the function has to come out of the condition or come out for the recursive function, and the second one is general case. Every time the recursion execute, it has to reduce the problem. So that is the two cases what we have to make a note on that. A recursive function should never generate the infinite sequence. Recursive function should never generate infinite sequence. For this purpose only, we have defining the base case. Right? An algorithm exhibits this sequence of calls will never terminate. If it is goes to infinite sequence, algorithm will never terminates. If the base case does not exist, no recursive function can ever be completed. Because of this base case, we are coming out of the recursive function. We are coming out of the iterations. So, base case is very important. Clear on that? Next, we move on determining the base case. How we are going to determine the base case as well as a general case. Condition, you know why we have to determine the base case, and how we have to determine. Let's see. A base case is a specific case whose solution can be obtained with using the recursive calls. This also called as base case or terminal condition. Base condition, or we call it as terminal condition. Each recursive function must have, what we are saying here, it must have one base case. A base case serves two purposes. Why we are using the base case, or why we are determining the base case? To serve two purposes. One is it acts as a terminating condition. If base case is not there, your recursive function does not come out of the iteration. So it acts as a terminating function or condition. The recursive function obtains the solution from the base case it reaches. Once we reach the base case, then only we can get the complete solution of the recursive function. These are the two reasons why we have to determine the base case. Next, see why we have to determine the general case. General case, it is a portion of the code which contain the logic required to reduce the size of the problem. What we are doing? We are reducing the size of the problem to move towards the base case. As when we are reducing the size of the problem, if I have 5 iteration, each iteration I am reducing by 1. So, I am reaching to the base condition or terminal condition. Here each time the function is called, the size of the problem is reduced. Okay. So, this is how we are determining the general cases. Finding the factorial of a number using the recursive function. This is one of the basic example what we have or what we are using to demonstrate the recursive function. So, what is a factorial? How to find the factorial of any number? Factorial of 5 means how you are going to find the factorial. Factorial of 5 is equal to what? It's a product of all the numbers into 3 into 2 into 1, right? So, factorial of 5 is equal to 5 into 4 into 3 into 2 into 1. What you are going to get? The product of its previous numbers. So, when we have to determine the factorial of 4, what I am supposed to do? 4 into 3 into 2 into 1. And factorial of 3 would be like 3 into 2 into 1. So on. Like whatever the previous number, the product of the previous number will be the factorial of this. You can see here, this much, the portion is equal to this. This is equal to this. So, what I do, I replace this place by 3 factorial. So, how do I represent? 4 factorial is equal to 4 into 3 factorial. We have already computed the value for the 3 factorial. Instead of doing it again and again, what I am doing? I am giving the value of 3 factorial directly here. Right. Similarly, I can do how I can do 5 factorial. 5 factorial is equal to 5 into this 4 into 3 into 2 into 1 completely will be replaced by 4 factorial. So that is 4 factorial like this. So what I am doing, I am computed here, this computed value I am using here. That is what the recursion. Each time what we are doing, we are reducing the size of the recursion. Thus the above procedure can be generalized, and the recursive definition to compute the n factorial is expressed as if. What is this? If n is equal to 0. We are giving the condition here. Until unless how long we are supposed to do this, the same function or the same expression computation, until n value is equal to 0. That is a base case or condition. So n into n factorial, n minus 1 factorial. What is my n value here? 5 into factorial of n minus 1. 5 minus 1 is 4 factorial, right? So each time we are reducing it by 1 if n value is greater than 0. 5 is greater than 0, the condition true. So n value is greater than 0. So what I am doing? N into factorial of n minus 1. I am calling this function for minus 1 as this is my recursive function. Calling the function for n and calling the fact function for n minus 1 within the fact of n. So this is an example of recursive function, finding the factorial of n number. And then moving on to the type of recursion, we have different type of recursion. One is direct recursion and second one is indirect recursion. What you meant by direct recursion? Again, the direct recursion is subdivided into different types or different subcategories, we can say. Let's see what is direct recursion. Direct recursion subdivided into different subcategories, that is tail recursion, head recursion, tree recursion and nested recursion. We'll see each type of the recursion one by one. Let's see first what is a direct recursion. In direct recursion, function calling itself directly. There is no much headache. If I am using function, it is calling itself. Called and calling function both are same. That is called as direct recursion. If P is a procedure containing the call to itself, it is called as direct recursion. Here P is referring to the function name. When the function call itself within the same function repeatedly, it is called as direct recursion. Structure of the direct recursion is this. This is function definition and this is function calling. Definition and function calling. Okay. So this is a simple, very simple direct recursion. Next what we have, indirect recursion. Indirect recursion is exactly same as that your associative property. What associative property says? A is equal to B, B is equal to C. Then what I am saying? A is equal to C. Indirectly A is equal to C. Same thing holds good in the indirect recursion. You are calling function n, you are calling function 1 of n. Okay, when you are using function 1 of n here, function 1 of n, in this function you are calling function n. So this is indirect recursion. Function n calling function 1 of n. When it calls, it will go to the function 1 of n. This function 1 of n calling function n indirectly. That is your indirect recursion. When the function is mutually called by another function on the circular manner, the function is said to be an indirect function or indirect recursive function. Then this is an example for indirect recursive function. Here we have a function 1. Function 1 is calling function 2. Function 2 is defined here. Function 2 is defined here. This function 2 is calling function 3. This function 3 is defined here. And this function 3 in turn calling function 1. That is indirect recursion. Here they have taken 3 levels of indirect recursion. Next what we have is tail recursion. If any recursive function is called as last instruction or the last statement of the recursive function, then it is called as tail recursion. Example, I can take function is a recursive function. Here I am calling function. After this recursive function call, there should not be no statements. There should not be any statements after this function call. Such type of recursive function is called as tail recursion. If the recursive function calling itself and the recursive call is the last statement in the function, then it is known as a tail recursion. Then what is head recursion, or it is called as non-tail recursion? It is called as non-tail recursion. We call it as head tail or non-tail. Okay, here in this particular example, the recursive call of the function should be the first statement of the calling function. Getting? Here, before this function call, there should not be any statements. Such type of the recursive function is called as head recursion, or it is called as non-tail recursion. The function called non-tail recursion or the head recursive, if the function takes the recursive call itself and the recursive call must be the first statement in the function. So then it is called as head recursion. The other type of recursion is tree recursion. What do you mean by tree recursion? The function is called tree recursive if the function takes more than one calls to itself within the recursive function. That means what? Here take an example. Function is a recursive function defined with so many parameters and the definition, then calling the function more than one time. Right. Calling the function more than one time recursively. That is called as tree recursion. Next comes what we have is nested recursion. In this recursive function, the recursive function will pass the parameter as a recursive call. That means recursion inside the recursion. Example for this nested function, we have a number of statements. Function, within this I have a n parameter function n minus 1. Right. This type of recursive call is called as nested. It is passing the recursive function as a parameter. Passing the recursive function as a parameter. That is called as nested recursion. Tree recursion, calling the recursive function within itself more than one time, and nested recursion, passing the recursive function as a parameter for calling recursive function. That is called as nested recursion. Next, we'll move on to the recursive technique example, a general example to find the GCD of two given numbers. This is one of the example where we are using the recursion technique to compute the greatest common divisor. What GCD stands for? Greatest common divisor. GCD of two number is defined only for the positive integer, not for the negative integer and the floating point numbers. Just we are doing the GCD for only the positive integers, not doing the negative or floating point number. Let us have a piece of program. So what is this? As all of you know, when we are using standard library function, input output function, we are using the standard io.h for input output header file and conio.h. Whenever we are using the mathematical function, we are supposed to include the math.h. If not, we are using stdio and conio.h. Here what we have is int GCD. We are passing two parameters a and b because we are calculating the GCD for two integer values. So it will be int a and int b. This is a parameters passed for the GCD function. Which type of the function? This is a user defined function. Right. So once we have function declaration, this is a function declaration telling the compiler that we are going to, or I am going to use this function in my further coding. This is a function declaration. So going to the execution part, void main, it will declare the variables, how many variables we want. We want two variables, a and b, of the type integer. And next what we have is clear screen. You know what clear screen will be used for. Then what we have, a printf statement to enter the value of a and b. Using the printf statement we are entering the value of a and b, and using the scanf we are reading the value from the keyboard. Then print GCD of %d and %d. What is %d? The value we have given for a and value we have given for b is %d. What is %d? %d is a resultant value that is read by GCD of a comma b. Where we are calling the function? We are calling the function here. Once the compiler, once the computing point comes to your GCD of a comma b, then in turn it will call the function GCD. It will call the function GCD. This is a function definition. We are defining what we have to do when we call this function. Here we are passing two parameters m and n, which takes the value of a and b that is read in the main program if checking the condition n is greater than m. In that case, what we are doing, if we are taking 60 and 40, n is greater than m, what we have to do? We have to return the value that is computed by GCD of n comma m. Okay, this a value will become n and b value become m. Okay, so what we are doing here, we are checking if the n value is equal to 0. If the n value is equal to 0, condition true, then return the number. Return the number, either it may be m, or else if this condition fails, what I supposed to do? I should call the GCD function again. So this is a recursive call for the function GCD itself. Okay, that's how we are going to compute the GCD of any two integer value using the recursive function. Hope all of you clear with that. This all for the session. Thank you.